Hi, welcome to this series of videos on electricity, Unit P5 for students studying OCR 21st Century Science. This video deals with voltage and current, two of the key ideas for circuits along with resistance, and in this video we're going to look at the definitions of both voltage and current, the units, the relationship between them, how you measure them, and introduce you to a model called the rope model, which is a very powerful tool in visualizing what goes on in a circuit. Right, let's get started on the definitions then. So first of all, current. Current is simply defined as a flow of charge. Now we are dealing mainly with electrons flowing in metals, although you can have other currents of positive ions flowing, for example, in electrolysis in a solution. But we are dealing, in almost all questions in OCR, deal with electrons flowing in metals. So usually electrons. Quite simply, the bigger the current, the more electrons are passing a point per second. Okay, so it's a flow of charge, and the measurement of current is the rate at which charge passes a point in a circuit. So you can have electrons moving quickly, electrons moving slowly, or you can have lots of electrons moving or few electrons moving, and they all affect the size of the current. So just as an example, if I have a conductor here, and these are my electrons all flowing past, then you can think of the current as a measurement of how many pass this point every second, or how much charge passes a fixed point every second. So if we visualize like a line across here, how many electrons will pass through that line every second gives us an idea of the current. So if you want to have more current, you can have these moving faster, or if you had a much bigger conductor, I won't draw all of them, but you can clearly see that in a wider conductor, for example, the number of electrons passing that point is going to be bigger than in this one. So the current really depends on how many electrons are moving and how fast they're moving. One problem that pupils often get into trouble with is they say that the current moves faster. And we really just want to get into the idea of the current being bigger or smaller. So bigger current means there's more electrons passing by per second, and a smaller current means there are less. It doesn't necessarily mean they're moving faster, because if you have a tiny conductor like that, then clearly the current in that one is likely to be quite small, simply because there are less electrons that can pass by every second. So think of current as a measurement of the flow of charge. Strictly defined, it's the rate at which charge passes, or the charge per second, but at OCR they don't deal with that specific definition, so we're going to avoid it for now. And think of currents either being bigger or smaller. You can increase the size of a current or decrease the size of a current depending on the conditions. But current is a flow of charge. Now, voltage we are going to later define this as something slightly different, but for now we're going to call it voltage. Later on we will call it potential difference, or PD, but for now we'll just think of the idea of voltage from a battery. So if we think about electrons, the reason that electrons move is because they're going to be attracted towards a positive charge and repelled by a negative charge. So you can get that effect by attaching the ends of your conductor to a battery. So when you attach the battery, the electrons will be attracted towards one end of the wire because opposites attract. And if you think of electrons as just things that will be attracted towards positives, and the bigger the positive, or the bigger the difference between the positive and negative, the more attraction they have, then that should be enough to get you through at this level. So electrons flow because of the difference between the positive and the negative at the ends of a conductor. So we can think of voltage essentially as the size of the difference between the plus and the minus. So we tend to think of it at the most basic level as the size of the push on the charges, in this case electrons. The bigger the push on the electrons, then the more electrons will move, or the faster electrons will move. So if you have a big push, you tend to get a bigger current. And if you have a smaller push, you get a smaller current. We'll come back to the idea of potential difference later. But if you think of voltage as push, that should be enough to get you through for these first few ideas. Okay, so we've defined current as flow. I'm just going to go back and say that the symbol that we use for current is I, and the unit for current is the ampere. And that's normally shortened to amps, or just A. And for voltage, the symbol is V, and the unit is the volt. And that's usually shortened to a big V. Pupils often get tied in knots with the fact that the symbol, which represents it, is the same as the unit, which is what it's measured in. Okay, so just remember, current is symbol I, its units are amps, and voltage is measured in volts. So when we're measuring voltage and current, we have to use an ammeter or a voltmeter. Now, for measuring current, we don't want to affect that current too much, but we have to measure the flow, so we use something that's in the main part of the circuit, and that's called an ammeter. And the ammeter effectively measures the charge passing through it. Measuring voltage is slightly different, and again we'll come back to refine it as potential difference later. But when you're measuring voltage, you are essentially measuring the difference between two places in a circuit. So when you're measuring voltage, you set your voltmeter up in parallel, which means it's around the thing you're interested in measuring. Remember, current is a measure of flow through something. That's why the ammeter is in the main part of the circuit. So for example, I'm measuring the current through this bulb, the current flows through the ammeter. But when I'm measuring the voltage, then I'm measuring between 2 points on the circuit, and I don't want to have any influence on the circuit apart from just touching on the circuit on those 2 parts. So, how is voltage affected? So how are current and voltage related to each other? Well, it's quite simply this, that if I give the electrons a big push, that means it's a big voltage, then that's going to cause more electrons to move. So I end up with a bigger current. Now it's very, very, very important to remember that it's voltage that affects the current and not the other way around. Current responds to the voltage that's creating it. If there was no voltage, you wouldn't have a current. The electrons would just be moving randomly, and the bigger the voltage you apply, the bigger the current you get. Now we will go on later to look at something called Ohm's law, which enshrines this in a more mathematical way, but essentially we have voltage and current, and they're related to each other like that, which means as I increase the voltage, the current will go up as well. That's assuming all other factors are the same, so the temperature of the conductor makes a big difference there as well. So, just to recap, a current is a flow of charge. The more charge that flows, the bigger the current. Voltage is the push which causes the current to flow. We measure current by measuring the flow through it with an ammeter. We measure voltage by connecting at 2 points in a circuit to measure the difference. And the relationship between the two is that as you increase the voltage, you get a bigger current. Last thing I want to introduce you to is the idea of the rope model. So if you imagine a circuit modeled like this part here, this hand, represents the power supply or the battery. So this attempts to push the rope and make the rope move round in a circle. This hand here represents a component in the circuit, for example, a bulb. So this hand provides energy, and it's pushing the rope. This hand is resisting the flow of the energy by gripping it. So the friction between the hand and the rope tends to have an effect on the speed that the rope moves. But the important thing here is the idea that this hand will get hot because of the friction between the rope and the hand. Whereas this person will eventually get tired because they are constantly providing energy for this circuit, and the rope just carries that energy around. So if you think about this, voltage is represented by how hard you pull the rope. And current in this case is measured by how much rope passes a fixed point in the circuit every second. So the current is how much rope passes by. If I increase the voltage, that means if I pull the rope harder, then the rope will move faster, so I get more rope passing per second. Okay, so we'll come back to that model a lot, but try and visualize that idea of something providing energy for the circuit and something then that transfers the energy into another form. For example, it's transferring that into heat energy.